Okay, in this tutorial, I'm going to walk you through how to perform simulations. We'll start off with what's referred to as a DC or bias point simulation, which is used to provide you with a point of reference as to what the static voltage and bias currents are for a circuit and equilibrium. The second one will be a sweep. We'll sweep a DC source. The next one will be a transient simulation, so in time. And the last one will be an AC sweep, which will be a sweep in frequency. That one is commonly referred to as a Bode plot. And I will go in and show you how to use the advanced probes and plot gain and magnitude, or phase. A couple of things to note on this tutorial. I'm going to show you how to perform all the simulations that you'll need for this course. There are many more other options or more advanced topics. They will not be covered in this course. But not all of these will be used in the first lab, but they will be used in subsequent labs. Okay, to get started, we have our two circuits here. We have our non-inverting amp and our inverting amplifier. So the first thing that we're going to want to do, I always like to do is save. If there is a edit or a change in the schematic, typically you'll see an asterisk up here. So to get started, to perform a simulation, you're going to want to go to PSPICE on the toolbar, click on New Simulation Profile. I'm just going to call this one Lab 2, hit Create. And you'll notice nothing pops up, but if you look on your taskbar down below, you'll see this yellow icon where you have to choose a product. We're going to use the Allegro PSPICE simulator. So make sure you use the first one, the Allegro PSPICE simulator. Okay. And the next thing, you'll see this new icon blinking on the bottom down here for simulation settings. Pull that one up. So the first thing that we're going to do, as I stated before, is we're just going to do a simple bias point simulation. Let's see here. General settings. No, we don't need to save any of these. We're going to hit OK. We'll come up here. You see the green circle with the play button. We'll hit that one to run our simulation. And at this point, our simulation is actively running. And you can see the results present. So what you're seeing here is for a 6-volt DC input on both of the circuits, we're obtaining a couple of different outputs here. Don't focus on the values too much at this point in time. I'm just more or less walking you through the steps on how to see what you need to see. So you might ask, why am I only seeing voltages? Well, if you come up here, you'll notice that the only one selected is the Enable Bias Voltage Display. So we can click that and turn it off, come over to Current, and we can turn Current on. And you can see the current at different points in the circuit. Lastly, click that out here. We can turn current off. We can look at the power dissipation or generation. So a positive value means that power is being dissipated by the resistor, whereas a negative value means that power is being generated by the source. Let's see here. Lastly, if you want to look at all three, I believe you can turn them all on at the same time. The problem is you might get some overlap like here, and it makes it a little difficult to read. So for now, we'll turn all these off. We'll come down here. This is our simulation environment that's still running. Let's see here. I'm going to minimize that. Okay. So the next thing we're going to want to do is to do a sweep. So we're going to come up to PSPICE and edit simulation profile. So this time we're going to select, let's see here, DC sweep. So we're going to need to name a source. This is where you need to pay attention because you can only sweep one source at a time. the way we have our circuits drawn, we have two different sources driving the input. It is possible where you could have one source sweeping, driving both of the circuits, but just to keep things simplified and make sure that we don't get any values mixed up, we're going to keep it drawn as is. So for this point of the simulation, we'll focus on the non-inverting amplifier. So the first thing we want to do is identify a sweep variable or voltage source. So here you'll notice the name is V4. So I'm going to type in V4, and we're going to perform a linear sweep. There are many other options, which we'll not use in this lab, but I'll just point out. You can do a logarithmic sweep, or you can even do a value of like specific points that you want to sweep or hit. So we're going to go from, say, -6 to +6, since we have a dual supply, and we'll do it in 100 milliamp steps. So this is the resolution of the sim. It's going to start at a value of -6, and it's going to increase by 100 millivolts all the way from -6 to +6. Do 0.1 for 100 millivolts. Hit OK. The next thing we're going to want to do is put down some probes. This is very similar to putting an oscilloscope probe down. We're going to want to see something that's changing with time. So I clicked on the V probe right up here, which is a voltage level marker, and you'll notice a probe appeared. You can hit the R key if you wish to rotate it to different positions. So I'm going to put one here, rotate it, we'll put one here, and we'll put one here. So now we have one on the output, one on node VP1, which is the source that's driving it, and one on VN1, which is the virtual ground node. We'll come up here, go ahead and hit play, and you're going to notice that you see 3 plots right off the bat, and they are labeled according to color. You got green for your V out, red for your VN, and blue for your VP. To close this out, you hit the X. I will point out there are multiple capabilities within the screen capture right here that I'm not going to go into right now. But there are the capabilities to add traces. There's tools for performing measurements through the calculator. My recommendation would be, if you want to use those for a particular subject, to go to YouTube and perform a search, and there's a high probability you will find a video that provides step-by-step instructions on how to perform a given task. Okay, so let's close out this plot. And close this guy out. And you always want to make sure that you're not closing out your simulation environment here. Okay, so that was a DC sweep. Let's move on to the next. PSPICE, edit simulation profile. And let's go to a transient sweep. So for our transient sweep, we need to pick a runtime and start saving data. Typically we leave that to default at 0. So for the runtime, typically I prefer to plot 5 cycles as a good number, so 5 periods of your input signal. So our frequency is 10K, so let's think about this. A megahertz is, I believe, 1 microsecond. So 100 kiloseconds would be 10 microseconds, and 10 kilohertz would be 100. So let's run it for 500 micro. I could be wrong, it is late at night. I'm thinking off the top of my head at this point. For the maximum step size, we'll leave that at the default or the blink value for right now, and I'll show you why you might want to change that later. Hit OK, and let's come up here and hit the run, and we come down here, and always you want to come down here and click on this plot and take a look at this guy. So let's see, what do we have here? Looks like we have our peak to peak value here. That's looking pretty good. It's going from 6, that'd be about 7, so it looks like it's about half a volt peak, so about a volt peak to peak. we'll notice that VN1 and VP1 are flatlined. That might be because of our bias condition being at 6 volts. So let's come back here. I'm going to make a quick change on that. I'm going to put our offset, or DC positioning of our signal, right in the middle at 0. Save that. And we'll go ahead and run it again. There you go. So now all the signals are present. Again, if you encounter that problem with your running your simulation and you're not getting all the waveforms that you expected, that's something to clue you in. You might want to go back and look at your bias condition. Maybe your input is not biased appropriately, or even your voltage source is biasing your op amp are incorrect. So for this one, I just want to point out again, you can see the same signal traces. Everything is in phase. And by in phase, I mean that as V out, Vn, and 1 and Vp1 go to their max, they all follow each other. One thing you'll probably notice is that this is not really a very clean sine wave. It's kind of, basically it looks distorted. Well, the reason being is because of the time step. It's jumping from here to here, and for each discontinuity in the line as it jumps around, it's going, essentially drawing a point-to-point line. So if we want to have a higher degree of resolution, what we want to do is come back to PSPICE, edit simulation profile, and let's make it really small. Let's make it 1 microsecond. Now the one thing to note here, for this simulation you're not going to notice a difference, but for really large scale circuits, if you make the maximum time step too small, it might take a long time for the simulation to run. So hit OK, hit the go button again, and pull it up, and now you see a very clean sine wave with no distortion. So again, if your sine wave looks distorted or not as what you expected, it might have something to do with your simulation step. Okay, so we're going to close this one out. That's your transient simulation. The last one that we're going to perform is we're going to go to Edit Simulation Profile, and we are going to perform a AC sweep. So keep in mind the starting frequency can never be 0 for an AC sweep. It always has to be a really low value. Common is to start at 1 hertz. Go to 1 gig. How many points per decade? Let's see. Just do 100. We want to do AC sweeps for a Bode plot are typically done on a logarithmic scale by the decade. And one thing that we're going to change here is we're going to perform a Bode plot. So we're going to get rid of these voltage markers here. And we're going to put down some more advanced pins on the output to plot the gain and the phase of our circuit. So up here, we're going to go to PSPICE, Advanced Analysis, nope, Markers, sorry, Advanced. So again, you want to go to PSPICE, Markers, Advanced, then you got dB magnitude of voltage, current, phase of voltage, and so forth all the way down. So we're going to do dB magnitude of voltage. This is the first one. That's the typical pin, marker that you'd use for your gain. So that takes 20 times the log of the voltage value. And we're going to go to PSPICE. Again, it's pretty far down this menu here. Markers, Advanced, and phase of voltage. I'm going to rotate that guy. So that'll provide 2 separate plots. I'm going to save this and plot it. And that was quick. So here what we're seeing is you have your voltage gain in green coming across and rolling off out here. Then you have your phase coming across and it's rolling down. And then we have some unique attributes further out in frequency. So that concludes how to perform a Bode plot to this point. Let's see. So again, to recap, we performed a DC bias point, a DC sweep, a transient simulation, and an AC sweep. So going back through the sources here, the V off, that is your DC component of your input signal. That's what we swept. Your V amplitude, that is your peak value of the sinusoid that you're applying, and it's with a frequency, in this case, of 10 kilohertz. AC is strictly used for the AC sweep, so it has a gain of 1. It's very common that we use a value of 1 on the input, so that way the ratio of the output to the input is just simply whatever the voltage is out here over 1. It's a little bit more, it's just straightforward arithmetic then at that point, just 20 log of the output. For the transient, the only two components you need are the amplitude and frequency. And for the DC bias point or DC sweep, all you need is the offset value. That concludes this lesson for how to perform simulations.